neutron to proton ratio is another important factor which can be used to assess the stability of a nuclide. When we plot number of neutrons versus number of protons for all the stable nuclide, then we get a graph which is called the Sagres chart. In this plot, each dot represent a stable nuclide. If an element has more than one stable isotopes, then for a particular value of Z, more than one dots may appear. For example, for atomic number 1, 2 dots appear representing hydrogen 1 and deuterium. For atomic number 8, 3 dots representing oxygen 16, oxygen 17 and oxygen 18 appear. Now this area in which these dots are distributed, this area is called the zone of stability. And looking at the distribution of these dots, it can be concluded that for lighter nuclides, the number of neutrons is nearly the same as the number of protons, except hydrogen, for which the N by P value is equal to 0, and helium 3, for which the N by P value is 0.5. These are the only two stable isotopes with the neutron to proton ratio less than 1. All other elements up to atomic number 20, they have N by Z ratio 1. For intermediate nuclides, the N by Z ratio is higher and it is around 1.4. And for heavier nuclides, the value is close to 1.5. Now if for a particular nuclide the N by P ratio is outside this zone of stability, then that nuclide will be unstable and it will try to get into this zone of stability by emitting radiations. Now lead is the heaviest element with a stable isotope and its N by Z value is 1.54. For uranium 238 and plutonium 224, the N by P ratio values are 1.587 and 1.596 respectively. And since these values are not within the zone of stability, therefore these isotopes are radioactive. Now the summary. In this lecture we have discussed the stability of nuclides, and we have seen that the even odd nature of number of nucleons and the neutron to proton ratio, they has an impact on the stability of nuclide, and the nuclides with even number of protons and neutrons, they are the most stable ones, and the lighter nuclides with neutron to proton ratio close to 1 and heavier nuclides with neutron to proton ratios close to 1.5 are stable. Now these are the two questions for you. You can check your learning by solving these questions. Question 1. Based on the even and odd rule, you have to predict the stable nuclide in each pair. And question 2. Based upon the n by p ratio, classify each nuclide as stable or radioactive. Now these are some of the books which I have consulted for this lecture. And thank you. Allah Hafiz.